two speakers are going to be Dante and Phil, and well, they are talking about the VV survey description, goals, and highlights.
Thanks very much, Andre Nicolas. It's great to be here. They asked me to give a slight review for the non-VVV people, and this is always quite fun. But because this is a 10th VVV meeting, and I've done this at least 10 times, so no problem. This is a huge group that is led by Phil Lucas across the room and myself. That we've been working all together for many years. So it's a whole number of people and people that come and go, but most people, like the ones that you see in this room, are happy with the survey. And what we do is that we map the worst part of the sky, the most where all the dirt is, where all the stars are. There's a lot of crowding and interstellar dust, and it's really impossible to study. So most surveys really stay away from the galactic plane, but that is where most of the interesting things are happening. In particular, the central region, which is marked by the box there on the right, which contains the galactic center. This is an optical picture, of course. In the infrared, we go through the dust and gas, and we are also part of one of the ESO public surveys. There were other 6 original ESO public surveys, and we are the ones that explore 3% of the sky contained in the central region, but there are other surveys listed there. This is a whole perception of the sky, wherever it's above and wherever is underneath also. And we started, the proposal writing started around 2005, but the final observations for the VVV survey were completed in 2015. It was very successful, and we got now an extension that it will go beyond 2020. And the idea originally was to map 560 square degrees, 1 billion stars, about 100 epochs, and about 1 million variables. But now we are mapping a couple billion stars, and the variables are more like 10 million. And we are approaching 100 epochs in some fields. And we use the Vista Telescope, which is the best near-infrared telescope in the world with a wide field camera. It's a large telescope. It's 4 meters compared with 2MASS, for example, which was half the size. It's optimized for the near-infrared, and it has a large field of view. It's located at the ESO Paranal Observatory. And it's been working quite well. It was out of commissioning last month because they were recoating the mirror, but it's doing just fine. And all the information you can find in the webpage, vvvsurvey.org, that is maintained by Josh Cullen there in the back, and all the data that is available for the world is done is at the ESO archive. But there are also the CASU archives and the VSA archives that are very useful, especially for the team members. And what else? We've counted about 185 reference papers so far, but I'm sure that we are missing some. And the main idea is that the photo album of the Milky Way is not complete yet, especially in that region. This is now the 2MASS all-sky meeting, all sky image. But you can see the Magellanic Clouds down there, but the galaxy shows up as a clear disk with a central bulge. But unfortunately, what you see in the central region is not real, because 2MASS didn't go deep enough. It could not penetrate the dust, it could not look through the whole galaxy, which we can. But of course, 2MASS is an all-sky survey, and it's very useful. It was fantastic. But if you take a typical tracer like a red giant, a red clump giant, or an Ira Lyrae, 2MASS will see that almost to the galactic center. We see them all the way through. in that region. But the best way of comparing both surveys is just by looking at a random image of the sky. You see that there is an improvement, not only in the depth, you can see much fainter sources, but also in the angular resolution, which means that you can also measure really good positions and therefore proper motions in this region where Gaia is not so useful. This is a real image of the center region of the Milky Way. Galactic center is there. This is 300 square degrees. It's a combined 400,000 individual images combined into a single picture. This was done by Ignacio Toledo when he was an undergraduate student 10 years ago. And we are quite proud of this. And this is a region that we are investigating. The main scientific goal of the VVV survey is to study the three-dimensional structure of the Milky Way. That was like our original aim. But of course, the slide made by Phil Lucas, we have a very specific goals and things that we have done during these past 10 years. Concerning galactic structure, concerning variability, and even astrometry. So we are going to share the slides, so I'm not going to read them all in detail. But please bear in mind that even though we are observing 5 passbands, Z, Y, J, H, K, S, this is for the VVV survey, the variability is only done in the KS band. And for the extension, the VVVX survey, we only observe we only observe in 3 passbands in the infrared, JH and KS, with again the variability done in KS. And this was in order to save telescope time. But still the Z and Y observations are quite important. And if we get extra time, it would be nice to complete the VVVX area with Z and Y observations. The observing strategies, most of you know, at the beginning there were multiple color observations in order to get a whole map and do stellar populations, search for clusters. But then there were the variability images for many years. And then at the end, there was also multiple color observations in order to aid also in the study of long-term variability and in the proper motions. And the observations, as I said, they stopped for the VVV in 2015. The survey was complete, 100% complete. But now we are doing the extension for the VVVX in only 3 filters. I don't want to spend much time on this also because there is a talk by Maren who will also address some of these details. But the point is that there are so many things to do that we are not doing them all, but it's useful sometimes to list them just in case we can attract good collaborators that can help us deal with this tsunami of data. And here is just a sample of representative light curves. Just you see that they are high quality. I mean, they look like optical light curves, but they are in the near infrared, which is a lot harder than optical observations of variable stuff. And even rare events like microlensing, we have tons and tons of microlensing events, and even new kinds of objects that we cannot explain. There are a few that we are just working now that we cannot really explain, and maybe we can pick your minds so you can help us, tell us what they are. So the results are very many. Phil, should I go on with this? Or
oh, carry on, you're doing a good job, that's fine.
I'm using your slides. So.
Well, yeah, no, this was just to highlight some of the, this is what I showed to the ESO Public Service panel a few months ago, right. When we had to, we get asked to go and justify our survey every few years to ESO. And so they asked us to show them the science results. And so obviously we have the 3D structure results, and I particularly wanted to highlight the kinematic work which has come out in the last few years from the proper motion surveys, proper motion catalogues. So Lee Smith, who was originally my PhD student, he did a version, and Rodrigo Contreras has also done his own version at PUC. And I guess the difference with Lee's version is that he made it public, and so a lot of people, when we made the whole of VVV survey public with the proper motions, was that people who were professional dynamical experts like Wyn Evans and Orwin Gerhard got interested in joining the collaboration and doing their own science. And so that thing which I am referencing there as the second item is this VVV Virac plus Gaia DR2 velocity for confirming the X-shaped structure of the bulge and the bar. That was actually done. There were two papers written at the same time by Jason Sanders in Cambridge working with Wyn Evans, and also one by Orwin Gerhard's student working in Germany. And they kind of did a deal. They initially didn't realize that they were working on the same thing at the same time, and, but agreed to just publish both of them at the same time on archive, so that was all quite friendly. And it was just great to see that you can actually see kinematically the radial motions. If you show the picture, Dante, you can actually see the radial motions of the stars.
Yes.
It's on one of those. Maybe that went away, but oh no, okay. Yeah, but there is a picture in the paper which just shows that you can actually see the X-shaped structure in terms of the fact that the stars are following the X into the galactic center and back out again. So it's just correlated in a nice way. And the other things, of course, that we got from the kinematics were, I mean, lots of various things shown there. I mean, obviously Dante's discovery of the miniature globular cluster population was one of the nice unexpected things that came out of the survey. Jura has discovered a very large number of new star clusters, which I know that one or two people in the audience might be interested in. A nice paper by Dante mapped the edge of the galactic disk all the way around the Milky Way, so not just the near side, which had been done by 2MASS, showing that the stellar density turns down at 14 kiloparsecs, but doing it right way around the far side with VVV in the fourth quadrant and UKIDS in the first quadrant. It was a nice combination of data. And there's a picture there showing some of the parallaxes and proper motions of nearby objects. So we actually found a nice benchmark binary brown dwarf called Beta Circini B there, which is about 30 parsecs away. And that was the first discovery that popped out of Lee's proper motion and parallax catalogue. The one on the right, the VVV telephone number there, 1411, is actually the nearest new discovery in the survey. It's only 14 parsecs away. And that's quite an unusual parallax and proper motion curve because it actually loops back on itself. It's moving so slowly that the parallactic motion is bigger than the proper motion every year. And so you get this nice sort of loopy cardioid structure, which I thought I would show.
I think I skipped this very quickly.
Yeah. So obviously we've been working on young stellar objects for a long time and discovering a very large population of these objects that you simply couldn't see in visible light. So again, it's highlighting what you can do.
Okay, I just want to add one point. We have for the VVV survey paper, the 2010, we are one citation short of 500. Please cite this. Okay. So and this is what you were mentioning, independent work.
Yes.
From other people. This is from outside the VVV. And the data releases, I don't know if I'm going to talk about the data releases, but here is a summary.
Not
okay.
Just about data retrieval.
Yeah, data release is it's very important part of the project because we signed a contract with the ESO saying that we have to deliver to them all the data, high quality data. With the quality control done and so on. And this has been much the responsibility of Phil, who has done everything here. So, with the help of the CASO people and BSA people, but this is a huge job, as well as the job for the OBs that every year we have to do the observation. And we have to do thousands and thousands of OBs. This is what Manu has been doing for so many years, so efficiently. And then for the survey completion and extension.
Yeah, well, I guess the the extension happened, and it was supposed to be a 3-year extension, but they asked us, so starting in 2017, but they asked us to start early in 2016, which was great because we got continuous coverage every year from 2010 onward, at least in the original VVV fields. And because Foremost is late, we're now going into 2020, as you said, and we'll expect to carry on getting data, all of which is great for long-term variability and proper motions. And so I was just explaining to the panel that we have the winter fields almost complete and the summer fields are only about half complete. But Marin, I guess you're going to be talking about that, so I probably don't need to say any more about where we're going.
And so this is the VVVX footprint compared with the VVV one, and it's a factor of 3 in area and a factor of 2 in time baseline. So that helps for the variability and proper motions. Instead of covering this part of the galactic plane, now we are going to cover this part of the galactic plane. A slide like that. And of course, our survey is complementary with the many other surveys, but I'm really happy to say that this is done. This is one of the surveys that is 100% done. And we are going on with the extension, but many of the other ones are ongoing. There's so much to do by matching with these other surveys. So pay attention to that. Yeah. And so just to wrap up, there is a lot more to come, of course, with the LSST, which is going to map a much larger area of the sky. Our area is this small box on the lower left, but LSST is going to be like 200 times larger area. And my wish list is to have a Vira 2, which Lee Smith, in conjunction with Phil Lucas, are about to release us, and in combination with Gaia DR3. Gaia DR3 will be fantastic because it will improve the proper motions, but it will also give us variability. So this will be absolutely, it will improve things in the bulge a lot. I would also like to see much more use of the VVVX data, because myself and many of you are working on the VVV data still, but we have to start using the VVVX because you know, it's out there and it's very good and it's unexplored. And also, I was talking with Rob Benjamin here, who's a PI of GLIMS, in doing a unified VVVX GLIMS database. That will allow us to go deep in the galaxy and to understand extinction. I'm looking forward to the extension for not 2020, 2021, maybe even a little bit further, because Foremost is a little bit delayed. We are not going to go on forever, but there is a possibility to propose for new things. You know, if we need something specific, we could propose to ESO. There will probably be some window of opportunity there. It is not official, of course, because they cannot say this officially, but this is a good thing. And then another thing very enthusiastic is if we could write a Foremost follow-up proposal. This more from the Chilean side, because we will have access to Foremost. So it would be nice to put a complementary proposal. And on the longer term, if we can collaborate with the WFIRST, maybe even help them design a survey of the galactic plane. But my wish list for this workshop is if we can not just give talks but write papers. Get together and write 15 papers. We can do this. It's let's not do another normal workshop like we always do, but let's just get together and help me with my papers, and I guarantee I will help you with your papers. And so we get things done, and we have done this in the past. We did this in Castel Gandolfo when we met. We wrote papers, and we wrote the continuation proposal, VVVX, which was successful. Then we got another small workshop also in Aspen, and we did many papers. And so this is a great opportunity to do that. And I finish here. Thank you very much, especially yourself. Thank you.
Thank you, Dante. Thank you, Philip. Is there any question or comment for the speakers?
I have a question.
Yeah, sure.
Dante, how can I have access to VVVX data? I asked you a couple of times in the past, and
Good question. When I need VVX data, I ask around, who knows, and essentially Maren. I ask Maren,
I'm
can
in the
you,
right place.
but there's one point. I ask Maren, can you give me this data for this specific cluster? I do not ask Maren, can you give me all the VVVX
No, of
data?
course not.
That's impossible.
No.
Nobody can ask anybody to give all the. It's
But
impossible.
is there a way to
But
access
if you
an
have a
interface?
specific pointed needs, we can do it.
Okay.